Hey everyone, notes 6.2 are on transformations of logarithmic functions. So question number 1 says to use transformations to sketch the function y equals -2 log base 10 of x minus 4, and we're going to state the domain and the range. So the first thing I want to do is write out the general formula for a transformed logarithmic function. Okay, so it's we still have our parameters of a, k, d, and c. And a, remember, is our vertical compression or stretch. Okay, k is our horizontal compression or stretch. D is our horizontal shift. And C is our vertical shifts. And don't forget, A could also be a reflection in the x-axis. And K could be a reflection in the y-axis. Okay, so our general formula is going to be A. Instead of f of x, our f is log, so it's going to be log base b of k times x minus d plus c. Okay, so nothing new. The only thing that's really new is just the logarithm piece of this right here. Okay, so it says use transformations to sketch this function right here. So let's write out what all of our pieces of information we have here are. So we know a here is -2, and if a is -2, we know that there is a vertical stretch with a scale factor that's equal to 2, and we also know that there is a reflection in the x-axis. Okay, and then we also know that d equals 4 right here. So that means that we have a shift 4 units to the right. All right. So we're going to look for values that are powers of 10. So we know that essentially what this is saying right here is y equals log base 10 of x. But what that means right here is 10 to the power of y is equal to x. So if my exponent is -2, then x would be 1 over 10 squared, or 1 over 100, right? If our exponent was -1, then our x value would be 1 over 10. If our exponent was 0, then our x value would be 1. And then if our exponent is 1, our x value would be 10. If our exponent was 2, our x value would be 100. So remember, just like we did in our exploration, if we have logarithms, it's just the inverse of our exponential functions, okay? Now, since this 100 is just getting to be a really large number right here, let's just use an exponent that is between 1 and 2, just so that we have a value here that will make things a little bit easier for us. So I'm going to add one more value down right here. And the last value that I'm going to add is, let's try what happens if I have 10 to the power of 1.5. Okay, so 10 to the power of 1.5 means 10 to the power of 3 over 2. So just a reminder for what you guys did last year. So it's this 2 right here means we're going to take the square root of 10. And then this 3 up here says we're going to cube it. So just a reminder of what to do for that. But let's go ahead and type that into a calculator. So 10 to the power of 1.5 is approximately 32. So we'll say right here, 32 will correspond with 1.5. So now that we've have some values for our parent function, let's go ahead and do our transformation. So the first thing we have is a is -2. So that means that there is a vertical stretch with a scale factor of 2, and you're reflecting in the y-axis. So we're essentially just going to multiply y by -2. Okay, so let's go ahead and do that right here. So when I do my chart right here, x is going to stay the same values Okay, so we're still going to have this 1 over 100. We're going to have 1 over 10, 1, 10, and I'm just going to skip this 102 for right now, and I'm going to just go to 32 just because the 100 is just such a super large number. So then what I'm going to do is I'm going to multiply all my y values by -2. So this becomes +4. This becomes, this -1 right here becomes +2. This 0 becomes 0. This 10 becomes -2, and this 1.5 here becomes -3. So we've done the A value. Now the D value says that we're going 4 units to the right, so I'm going to add 4 units to every single one of my values here, to every one of my x values. So add 4 to x, and when I do that right here, I end up getting 4 plus 100 is 4 and 100th. 4 plus 1/10 is 4 and 1/10. Okay. 1 plus 4 is 5. 10 plus 4 is 14. And 32 plus 4 is 36. And then I'm just going to copy down the y values that I have. And I can put a check next to this because I've done this right here. So now I'm just going to graph out my parent function as well as my original function right here. Okay, so if you remember, the x values in a logarithmic function are always going to be positive, because when I do 10 to the power of any number right here, I'm always going to get a positive value. And also it's the inverse of an exponential function, which is always going to have positive y values. So our logarithmic function will always have positive x values. Okay. So I'm going to graph it out as follows right here, and I'm going to space it out so that I can kind of see everything that's happening here. So I'm going to label this my x-axis, label this my y-axis. I'm going to space this out. I think going by ones is fine. I'm going to do every other, so that way I've got some room for everything right here. Sorry, every other right here, this should be -2. -4, -6, and then I need to go out to at least 36 right here, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I go by threes, I think that would be a good idea. So this is 3, so we've got 6 here, 9, 12, so on and so forth. So for my parent function, my first x value that I have is 1 over 100, and then I have -2. So it's super, super tiny right here. Okay, my x value is really small. The next one that I have is 1 and 1/10. It's still pretty small, -1. Then I have 1, 0. Then I have 10, 1. And then lastly right here, I've got 32. We'll go with 1.5 right here. Okay. So here is my parent logarithmic function. Okay. Now let's go ahead and graph out our new function. So let's label this y equals log of x. And remember, if it's log base 10, we don't have to put the 10 there, but it's totally okay if we do. And then let's go ahead and graph out our new function. So our new function is at the first point that we have here is at 4 and 1/100th. So I'm going to go to 4 and then a tiny bit more, and then I'm going to go to 4 up here. Okay. Then I've got 4 and 1/10 is 2. Okay, not really much space between those two. Then I've got my y-intercept, or sorry, my x-intercept is at 5. Then I've got 14, -2. And then lastly, I've got 36, -3. And now, if you remember when we explored our logarithmic functions, the parent function always has a vertical asymptote at x equals 0, right? So we're on the y-axis. So this is where our vertical asymptote is going to be for our parent function. But if we had, if we wanted to draw out our new vertical asymptote, we will see that the graph has been shifted 4 units to the right. So our new vertical asymptote will occur at x equals 4 right here. So let me just adjust this and move this over a tiny bit. So that way we can see that our vertical asymptote is now at x equals 4. So that means that our graph is going to look as follows right here because we have that vertical asymptote in a new spot. Okay, and this right here is our new graph. So this is y equals -2 log. Again, we don't have to put the base 10 if 10 is our base right here. Okay, all right, so now let's take a look at number 2. In number 2, it says the logarithmic function y equals log base 3 of x has been vertically compressed by a factor of 1/2. Okay, so that means that a is equal to 1/2. Okay, it's been horizontally stretched by a factor of 3. Okay, so that means that k is going to be equal to 1/3. And it's also reflected in the y-axis, so k is actually going to be -1/3. Okay, it has also been horizontally translated so that the vertical asymptote is at x equals -4. Well, it was originally at x equals 0, so that means that it went up 4 units to the left. So that tells us here that D is going to be -4. And then it's been vertically translated 5 units up, so we know that C is 5. Okay, now we need to write an equation for the transformed function. Well, if we know that the general equation is y equals a log base b of k times x minus d plus c, here we can say y equals, instead of a, we know a is 1/2 times log, and our parent function is log base 3, so we have to put the 3 there, okay, times our k value here is going to be -1/3, okay, times x minus d. This minus d becomes +4, so we're going to say here that we have a +4, okay, close those brackets, and then plus c, so we're going to say +5. And this right here is our transformed function, okay. Then it asks us to state its domain and its range, okay? So remember, the parent function, no matter what the base is going to follow a general shape that looks like this right here. And we have a vertical asymptote at x equals 0. Well, our vertical asymptote is now 4 units to the left. So if our original domain was x is greater than 0, then our new domain has to be x is an element of the reals such that x is greater than, x is less than -4, because what ended up happening right here is that we ended up getting our vertical asymptote is at -4, but it was reflected in the x-axis, or in the y-axis right here. So here we're going to say that x is less than -4 right here. Okay, now the range will still be all y values, all real values, because it goes because we have a vertical asymptote here. It's going to go to -infinity, and this extends to +infinity right here. So our range is going to be y is an element of the reals. Okay, so let's just go ahead and graph it out in Desmos to verify that we got this domain and range correct, and then we'll be done. All right. So let's go ahead and talk about how to type this into Desmos right here. So I'm going to type in y equals, and then if I click right here on functions right here, I'm going to be able to see a bunch of functions, and I'm going to go to the miscellaneous functions, and I can see that I have log with a base here. So my log is going to have a base of 3. But let's go ahead and put this 1/2 in front first. So 1/2 log base 3 of -1/3. And then right here we're going to have, sorry about that, right here we're going to type in x plus 4. close our brackets twice, and then we've got our plus 5, and this is what our graph will look like right here. And if you notice, we do have a vertical asymptote at x equals -4 right here, and the domain is everything to the left of -4, and then the range is going to be all values of y. And although this looks like it's going to take a long time to approach infinity in the y direction, it will approach infinity eventually. It's just going to take a really, really, really long time to do that. Okay? All right, that's it for this video. Let me know if you have any questions, and I hope you have a great day. Bye.